pre-K through 5. I recognize some of you, becoming friends. Today's math that we're going to do is the hardest math that we do in elementary school. So, multiplying and dividing fractions. I learned it as a child. I learned the rules. I actually couldn't keep the rules straight, so I learned how to find one answer, figure out the rule that fit with that problem, and then I could solve the rest. That is not good math. I found a clever strategy to get through it, but I didn't understand the math. That is exactly what we're trying to break. We're trying to make sure that the kids understand the math. And I have to give you, we're going to do a 6-week course in about 50 minutes. Please come in, we know traffic. So this is going to seem possibly, very fast-paced. Of course it is. Remember that your child is having more time to develop their knowledge. And secondly, it could seem a little bit disjointed because we might have to stop one and abruptly go to the next topic, where in the classroom it would be a much more fluid learning process. And thirdly, your kids have been doing fractions. The previous unit was adding and subtracting fractions. They have been finding common denominators. They are used to using multiples. They know when they see 3 and a third and a fifth that a 15th might be a reasonable thing to think about. We haven't had that same practice, so it might seem a lot harder to you than it does to your kids, because they're in that mindset now. All of us, it's like any sport, it's like anything, the more practice we've had, the more time we've been involved in it, the easier it gets to us, and the more we start seeing the patterns, because really math is so much about patterns. So give yourself a break. If you're looking at it and saying, what in the world, please ask that question. We know this is, we're plopping you into fractions. If you've been cooking, you've probably been doing some of those manipulations with the fractions, but a lot of us don't use fractions day to day, or they've become so much part of our world that we don't think much about them. We're able to do it. We will get your kids to that fluency, but at first they need to understand what's going on. And that's what this unit is about. The 5th grade standard is not about fluency, it's about understanding, being able to build it and draw the model. 6th grade is when multiplication and division is fluent. What we mean by that is that they could read a problem or see a problem written down, and they could take out a piece of paper and pencil and do it just with numbers. Also, fluently might mean that they now understand it well enough, they know how to break it apart, and they can do it in their head. Right now, we want them visualizing it, we want them building it, and we want them drawing it. You should have a packet. You will need colors. Oh, great. No pressure.
Can I just take a minute to
Please do.
This is Irma Anderson. This is our parent group. Irma is the consultant that we've been working with her for probably about 10 years or so now. She's our guru for math and science and comes regularly to meet with our teachers and works a lot with Carol. So Irma just had a cancellation in her schedule. She was supposed to be working with the middle school team to reschedule, so she's going to pop in here.
I'm so glad she said next.
Yeah, there you go. And Carol just said, no pressure. Irma's in the room.
No pressure. Irma walks on water the rest of it. Okay. So I hope you heard my last spiel. Remember, today is the day about understanding, so we're going to start building things. You should have, we call these Unifix cubes or linker cubes. You're going to need a couple strands of them. There should be colored pens, and you should have a packet. We know that to understand it, if we build it, we can, that's our beginning of understanding, so we start every new concept by building it. In the unit, your kids have probably already started, they could be past this, but I wanted you to see what they were doing. First of all, a fraction is a form of division. It's a way of writing it. So they've known that if they have the fraction 1/4, it's taking a unit of 1 and taking it apart into 4 equal pieces. So 1/4 is that one whole divided into 4 parts. They can build it. When they've built it, they can take it and they can draw a model of it. This particular model, you've probably seen or heard the words tape diagram. It's not the only model, it's an effective model, and it was probably, well, we accept any model, but when they built something that looks just like it, they're probably going to draw what they've seen. So if this was 1, and we divide it into 4, how would we build 3/4? Pardon me? So if we have 3 items, and this is where I said your kids are coming off of a unit where they're very fluent and flexible with numbers. I keep wanting to show you where I should show you here. I have 3 units. I need to divide them into 4ths, which I can now do. So I can take my 3 and I can divide it into 4ths. Could you go ahead and build 2/3? I have 2, they're each in 3 parts. And what we didn't do on the previous one, where are my 3 parts? Here are my 3 parts. Here is 2 out of my 3. So when 2 were divided into 3 parts, we ended up with 2/3. I forgot to do back here on this first one. I'm a little rocked. Okay, so we had our 3/4. Here are my 3 parts. I need to divide them into 4 equal parts. And they each have the value of 3/4. Your students, your children build it and draw it, but they do get to that point of understanding it and can go to the model. So what is 5/3? Actually, I don't need these 2. I need to divide these into 3 groups. I think I just did this one wrong. I did need my 5. I did it by 5ths instead of by side. Yes.
Yeah, divided by 4.
There we go. Got myself rattled here. Where am I? I may need your help. have my 5 cards. Excuse me. I divided them. This understanding that a fraction is division is very much related to what they'll move on to into algebra. So all of these things are very aligned along the way. Fractions are, algebra is about fractions and understanding it just as the variables, so it's so important that they understand the fractions. Okay. Could you build a block of 10 or a stick of 10? We're going to move on. We've left just the idea of that a fraction is division. And we want to know fractions of whole numbers. So we're now using this as equaling 10. During our fraction unit, we talk a lot about what is the whole. Right now, this is 1, this is 2, or this is 3, this is now 10. If I want 2/5 of 10, if 2/5 of the 10 parents are wearing purple today, how many would that be? Well, I know I have 10 parents. I'm talking about 2/5 of them. It's 4. How do we get that? We're talking about fifths, so we need the 5 equal groups. So now we have our parents in 5 equal groups. And we have 2 of those groups. So 4 of the parents are wearing purple. We would build that. Well, let's do another one. How about 1/3 of the 12 soccer players scored a goal? 1/3 of 12. Soccer players scored a goal. How many goals were scored? Oh, is it really? How many are we going to start with? What is our whole? 12. What size groups are they? Or how many groups are there? So there's 3 groups. And we had 1 group that scored, so it's 4. In class, we do this multiple times. And as we're doing it, we start drawing the model alongside of it. So with 1/3 of 12, we have them. I always double check. So I have 12. I want my 3 equal groups. And we ensure that they're labeling it. These are the 12 students. I can see up here that I have the 1 group, and this is the students who scored a goal. If your child is struggling, they've got the built item right in front of them. As they get more fluent at it, the building does get cumbersome. You start getting into numbers that are not easy to build, but we understand that relationship now, so we're able to go to the tape diagram. To build 32 is perfectly reasonable for the child who doesn't see it, but a lot of kids can now hold that mental image, and so we can take it to the tape diagram. So would you turn and do with a partner, or do it by yourself and check with a partner, there are 32 students in the class. Of the class, 3/4 of the students bring their own lunches. How many students bring their lunches? So we're trying to get you to do it the way your child would do it. So if you would build it, how many would be in your hole? Okay, and at this point, you've had lots of practice building it. If you want to build it, fine. If you just want to draw the picture, that's fine. Right? So you've had plenty of practice that over many years. How about practicing the way your child would do it? So this is a representation of a real story or a real problem. We want to make sure they are labeling it. So these are the 32 students. I have them in 4 equal groups. When I'm looking at mine, I wonder if I counted wrong. How many of those groups brought their lunch? 1 group, 2 groups, 3 groups. 3 out of the 4 groups. I'm looking, I think I've got my numbers wrong, but that would be 32. Well, there's 8 in each one of these groups, so 24 students bring lunch. Does putting a label to the answer make a difference? Absolutely. This is real life. These are not naked numbers just hanging out there. It's funny that answering that, we call it the answer statement, it makes the children go back to the question to make sure they're actually answering the question that was asked. Because the question could have been, how many students buy lunch? Well, that's the other 8. So we want to make sure that their answer statement, that they label it, and it's a double check that they're actually answering the question that was asked.
Because last time we divided 3, divided the whole
Yeah.
Okay, this was 3, you were dividing 3 by 4. Now it's which one are we doing? No, it's 3/4 of 32. So we've taken those 32 students and we want them in 4 groups. How are we going to get those students into the 4 groups? And your students, as I said, they've been doing fractions for a while. They've gotten quite flexible. Maybe they don't know it's 8. Maybe they come up and they say, I'm going to be more accurate in my drawing. So if 3 out of 4, they could have grouped them into 4 groups, and they know that 3 of them brought their lunch. Maybe they see it another way, because there's maybe, okay, 3 brought their lunch, and 1 didn't. 3 brought their lunch, and 1 didn't. This is still a representation of what the question asked. They're going to have to, and this is, I'm concerned about my counting here. Did I get the same answer drawing it this way?
Supposed to.
I'm supposed to. Yeah, that's probably a good answer. In the class, I would probably expect to see both of these drawings. We would share both of them. They're both correct if done accurately. As we move along, I think more kids reasonably move towards the way we did it the first go round. It's probably a more efficient model. It doesn't mean that it's right, and it's not efficient if your child doesn't see it that way. It's only efficient if it works for your child. So can I save you 1/6 of 24? I'm going to do the same 24. How many groups am I going to have? 6. And how many, if I have 6 groups, how many children have to be in each group? And we could do the same thing. Would you like to try that one? I'm looking at the time. I'd like to move on to the third question. The New York Rangers hockey team won 3/4 of their game last season. If they lost 21 games, how many games did they play in the entire season? So what am I going to do with this tape diagram? Yes? Yep, we're going to go to 4 equal parts. Okay, let me do a, whoops, how? Okay, tell me which part, if they lost 21 games, how many games did they play in the entire season? They won 3/4. And then what else do you know? They lost 21. Well, this is the area that we know. And as I keep labeling it, I did not sit down and think, oh, what is the equation that I have to write and what do I do? I'm labeling the picture so I can then see what the question is about. So I was able to label what I do. Can I figure out the rest of it? Well, we know these are equal parts. We know this has to be 21, 21, 21. I know that they won 3/4 of the game. So now I go back. How many games did they play in the entire season? Not how many games did they win, which in my mind I was going to immediately. So they played 84 games. This statement, as I was going to fall into that trap, when you're asking me how many lost, I kind of immediately went to, well, then how many did they win? That's what a lot of our very capable students do. The details matter, and the situation matters. So we built a lot of them in class. We built and drew alongside of it. Many of the kids moved on, and then we do get to just the problems. In 5th grade, they should be capable of doing these. These are the problems they do. Abby spent 5/8 of her money and saved the rest. If she spent 45, how much money did she have at first? Would you work at that one at your tables? Don't think about solving it first, think about labeling it. Yep, so there's going to be 8 equal groups somewhere. without knowing how to do all of that, they can look at the picture. Now, fluently, we're going to do these, we're going to do these. The kids are going to start looking at stuff and they're going to start finding how to do that without the picture. They're going to develop that themselves as we go along because we keep, you know, we line them up in certain orders to help them get there. Do you and your table mates agree on how much money there was? So how much is 1/8? Okay, so you've got 5 of these, total equal 45. What's 1 more? We've got 45 divided into 5 groups. So understanding how to use unit fractions as a way to help you solve things has been something they've been doing for 2 years.
Do they learn that label the picture? My son does my study. Maybe I label it a different way, you know, we start, you know,
Okay.
having the fun.
So if you and your children are doing this differently, they need to take the lead. You need to listen to them. You need to ask them questions about how is this working. If when you're, I even hate to say this, it depends how closely what you're doing is to theirs. We don't want you to say, oh yes, yours worked, but here's another way. We want them to understand this way. We want them to make that knowledge and those steps to get to your way. They will.
That's exactly the mistake I'm doing.
Right. So you're wanting to jump in because you want to be so helpful and show them this easy way. This easy way is not easy if you don't understand it. And often there's several steps in there that they need to go through to understand it. And after drawing these, if you get your child to explain what they did, let me go back to the 1/6 of 24. If you get them to talk out loud about what they did, well, I took the 24, I divided it into 6 equal pieces. Oh, there would be 4 in each, and I need 1. All of a sudden, their language is sounding very much like the equation you're probably writing down. But they're seeing it and they're being able to explain it in words what it is instead of just using symbols. So they're going to get there. Now I want to take you down to the last one because the language is different. So Joaquin is icing 30 cupcakes. He spreads mint icing on 1/5 of the cupcakes and chocolate on the half of the remaining cupcakes. The rest will get vanilla icing. How much are we dividing this into? How many equal groups to begin with? 5. We know there are 30 cupcakes. How many are there in each of the groups? So if I label this, I now have mint. And chocolate on the remaining 1/2. Without drawing this to begin with, students would have seen the 1/5 and the 1/2. Just looking at numbers, they would have immediately gone, I need tenths, when you don't. That is grabbing at numbers and just manipulating them in a way that I think that I'm going to do instead of paying attention to the problem. Half of what's left. Can I figure out where half is of what's left? Sure, it's 2 out of 4. So if half got chocolate, the other half got vanilla. How many got vanilla? This is the type of problem that catches kids that just want to grab numbers and manipulate them. They have to understand what is being asked of them. Did you need to break this? Oh, you're doing the sixes. So through practice, they've learned to just label these. Some kids might have to see them as 6 pieces, but they are developing their knowledge as they go along with it. So these are fractions of whole numbers. In general, students understand this one. It's very concrete to them. We're going to skip on. In 5th grade, they need to be able to envision what multiplication of fractions is. There is 2/4 of a chocolate bar left at the table. Jose came in from playing and ate 1/2 of it. How much of the original bar did he eat? I don't know. Well, I have 1/2. That's what I have. Who came in? Chocolate bar. Jose comes in and he eats 1/2 of that. He eats this 1/2. How much did he eat? So there's a lot of development of showing the different pieces and understanding. If I had not drawn this across, I'm showing you that he ate 1/2 of 1/2, but we really don't know the value of it. Because I have to go back to where's my whole? So I cut each of those halves in half and I get 1/4. I know that some of the tools they use will show this going across. They'll show you 1/2 this way, and then their tool will show them 1/2 this way. It doesn't change the answer at all. It depends whether the child likes seeing it that way, and I also know that one of their tools, there are these overlays that they can put down to make it faster. But it's still showing the overlapped area is 1/4.